Previously, we've looked at the linear search and the binary search. One thing we have to keep in mind with our binary search is our array has to be in order. So let's take a look at what happens if our array is not in order. This is very simple to fix. So we're going to do two things. The first thing we're going to do is in our set random values, we are going to remove the ability to add the last value. So what this means is that our value is going to be constantly in a different order. So I'm going to need to sort this. Because my information is no longer sorted, I'm going to need to write a sorting function. Now, there's a lot of different types of sorting functions out there. Some of them are very efficient, but a little hard to understand, like the quick sort. And we'll actually look at that in future classes. And others are a little bit easier to understand and very simple, but probably not as efficient to run. Now, two of these is the bubble sort, which is one of the most inefficient sorting algorithms, and then the selection sort. We're going to use the selection sort, which is a little bit more complicated. It is actually shown in the book, and even though it is a little more complicated than the bubble sort, it still is pretty easy to figure out. So you do void. We're just going to give it a function name. Values is going to be my array, and then int array size. I'm going to need to find some starting variables. So I have an integer, and it's going to be my current minimum value. So you just start at 0, and int current min index, which I'm also just going to initially set to 0. So this is going to be my initial values that I'm going to use. And I'm going to use these inside of a loop in just a second, as you'll see. So I'm going to want to go through a loop, but I need to go through every item in my loop. So I'm going to say for int I equals 0, I less than my array size, I plus plus. So we've seen this many times before. What I'm going to do is I'm going to set my current minimum value and minimum index. My current minimum value is going to be values at I, and my current minimum index is going to equal I. So I have this part. Now I'm going to write an inner loop. And my inner loop is going to be used to test to see if my current minimum value is the minimum value or not. If it's not, and I find a smaller value, I'm going to replace the current minimum value and the current minimum index. We'll see how to do that in just 1 second. First, our inner loop. Once again, a for loop. J is going to start at I plus 1. J is also going to be less than the array size. The reason for starting J at I plus 1 is very simple. We don't need to test against our current value. We're going to start one value below what our current index value is. So if we start at index value 0, we don't need to test index value 0 against index value 0. We need to start at index value 1 and test against that. All right. Inside of our inner loop, inside of our for loop, we're going to need to see if we need to swap out the current minimum value. So what we'll do is real simply say if current minimum value is greater than our array values at index j. That would mean the value of index j is smaller. And if that's true, then we need to swap for those values. And we're not actually going to do the swap yet. We're just going to set this up. So what we'll do is we'll say current minimum value is equal to values at index j. And we'll say current minimum index is equal to j. This updates our current minimum value, so we're always looking for the smallest one. Once we're done with our inner for loop, we need to see if we actually need to make that swap. So what we'll do is we'll specify, so we'll use an if statement. We'll say if current minimum index is not equal to I. So if our current minimum index is not equal to I, then we've done some sort of swap. We found a smaller one. Swaps are kind of expensive, so we try to avoid them, which is why we waited till the end to do it. Now I'm going to update this information. So I'm going to say values at current minimum index is equal to value at the index of I. Values at the index of I is going to be equal to my current minimum value. What I've done up at the top is I've already created a function prototype. I'm printing out all my items, doing a selection sort, and then printing out my items again. Now if I run this file, I start off, I have a very unordered list. But now, once I've run it, you can see where I start with items at index 0, it's now ordered. If I go and run this again, I'm going to get different values, but after I run my selection sort, it's ordered. And I can keep on repeating this process. So my selection sort is a pretty easy to understand sorting algorithm, even if it's not the most efficient. And right now we just want to look at easy to understand versus efficiency. This is how I could take an unsorted array and sort it. That way I could do something like my binary search.